Last and not least, we've got Daniel Pearson. Daniel is the Data and Spatial Studies Chief with the U.S. Geological Survey. And he is here now to talk to us about enabling your groundwater data through dynamic web applications and visualization tools. It sounds like you're going to teach us how to bring our databases to life.
Sure.
All right, let's turn it over to Dan.
Thank you. So you could just put it on the top, the first slide, be great. So I can't tell you guys how thankful I am to be in this session with Aaron and Sam. I think it's actually a really nice fit. So, we kind of heard from Sam about laying the foundation for the future of these data services under this brand called the Internet of Water. And Sam mentioned the 2013 open data standards that the USGS currently falls under. So our data is publicly accessible through a number of different vehicles, and that's an exciting change for federal government. Aaron speaks to my heart when it comes to data wrangling, QA/QC, metadata standards, logical consistency, relationships. I mean, the reality is that's the world that we have to entertain to get to end products. And for me, that is, I know that's a daily conversation that he has. That's definitely a conversation that we have, even though we have a robust database like NWIS. What I'm here to talk about is the visualization component, and that is, so once all of that's done and we've got some of these data services, how can we get the data out to many, both for stakeholders, our cooperators, but the public and decision makers? And that's really where I'm at. I'm gonna go to the beginning of this. You guys just got a ton of preview. So I'm going to talk about that, and that's not to slight data collection. As we know, data collection, there's a number of regards where we collect new data using different methodologies to put under these umbrellas called databases. I'm going to run through a number of slides. I'm going to show some screenshots of a few applications, and then I'm going to kind of go rogue, and I'm going to demo a few of them live on the laptop here, and I'll make sure my voice carries it to the back of the room. But geospatial water data, as Sam mentioned, is kind of a challenge, but this is, I think, where a lot of this comes into the fold. Our water data is geospatial. It is ready to go. It needs to be prepared, curated, managed, and then we can get it out into applications. And the reason I mentioned communication is because that is a key component to this fold. It's not about just getting the data together and putting on, it's communicating the stories and narratives around that data, which really connects it to our end users. Either that's for operations, locally, it's to tell the narrative about current conditions of what's happening, but it also tells the science story a little bit better. So, modernization, this idea of data visualization and application development, it's been around for a number of years. Dating to when I started in the USGS in 2002, we had tools like ArcIMS that were some out-of-the-box Esri mapping solutions. But a lot of technology has accelerated, and these two quotes really kind of stick out to me. This first one from Scientific American: when scientists explain their work simply and more effectively, public communication increases the impact of that science in multiple dimensions. We know that when we communicate more effectively, we touch more individuals. And then this next quote here from the Walker Customer Intelligence has really gained steam here, but the essential components to this is, by 2020, customer experience will overtake price and product as the key brand differentiator. The root of this is that your experience with your data may be more important than the data itself, and it's definitely more important than price, that people are having a good experience when they come to your product. In this regard, it's groundwater data, but it could be flood information, it could be any sorts of water data that we're talking in the future, and that experience is really important. So what are the expectations? In 2018, these expectations are pretty hard to come by, but we mentioned mobile applications. Mobile devices are currently definitely in the fold. Open source technologies are rampant now. I mean, we had a few out-of-the-box solutions about a decade ago, but a lot of these open source libraries are available and easy to use these days. The idea that infographics can be used, so telling narratives or telling stories through simple graphics like you would see in the New York Times or Washington Post or USA Today, get to the point quickly in a very graphic and engaging way. I think that is a very important thing. Social media has definitely come into the fold. I'll mention that a little bit briefly for some of our data, but the idea that we could focus on this communicating to both technical and non-technical audiences is really coming into the fold. The other component that's here is that geospatial location services is really embedded into everything that we're doing these days. Whether you have access to a GPS on your phone or you're accessing Waze or what have you, water data is no different, and the geospatial location really matters in 2018. A few more expectations, and this is just broad perspective about visualization, but when a user comes to your platforms, essentially I think these are some rules that should be applied, but intuitive. You should be easy to use. Essentially if you have a robust help documentation to give somebody an idea about how to use this component or this application, we're probably missing the mark. The content should be dynamic and focused. So we can throw a lot of stuff into a visualization and lose the message very quickly. So focusing it, understanding the narrative and the story is really important. And then obviously innovative is really maybe our mark, but I would suggest it's the mark of most in here. We want to be innovative and we want to use tools that communicate really well. A little bit, Alan said that my title was the Data and Spatial Studies Section Chief. That was true, actually, when this was submitted, but we've done a little bit of reorg within our agency, and we currently now have a team of 15 folks that really, their focus is both geospatial science and then this cyber innovation where we do this application development. You see the overlap. These aren't mutually exclusive. When we get geospatial data, obviously we want to deliver it. This team works very hard to do that. And then this is now, from Texas, a nationally distributed team. So we have folks across the landscape that are contributing to this work. There's an R&D component that comes into play. Aaron mentioned the infrastructure, which is not trivial for either visualization or database engineering. And then the other component is that there's a collaboration here. The collaboration component is working with folks like you guys, groundwater conservation districts, municipalities, and that gets to my point here about the mission. So our mission as a federal agency is to best manage and deliver the nation's water resource, I'm lacking the slide here, can you tell? So to deliver the hydrologic information and understanding needed by the nation's water managers to best use those resources. And we accomplish that in cooperation with local, state, and federal entities. And we do this in Texas, just to be clear, even though we're USGS, we do this in Texas. And we have the benefit of a program that many of you probably know about. It's the Cooperative Water Programming, where we have matching dollars that we can bring to bear for science in certain cases. So if you have any questions about how we can work together, we have a booth out there. I see Greg Stanton and Megan Roussel and Jen Wilson, a handful of folks that are here to kind of talk about how we work locally as well as nationally. So from a data handling and delivery standpoint, I'll mention the existing frameworks that we have. So our science is delivered through the PUBS warehouse. This is where our science reporting happens, journal articles and proceedings. Our data delivery happens through NWIS for a lot of our water information, and I would assume most of you are familiar with NWIS in some form or fashion. If you've looked at a USGS stream gauge, that's NWIS. If you looked at a groundwater level in your backyard, that's NWIS. If you're looking at water quality, that's NWIS. We do have a new delivery mechanism that I want to make sure folks are aware of. It's called science-based. So when analytical or research products or a science product is put together, the data component as outlined by the 2013 Open Data Standards, are now available on science-based. So when that package of information is produced, the digital data is warehoused in science-based and made available. Metadata and the whole nine. So I wanted to mention those, but what we're going to talk about is web applications. And just why web applications is kind of a broad term, but I would say, broader perspective, we add the geospatial back into the mix. Decision support comes into play here. When we've got the data all packaged and managed, and now we have this visual, we see trends that we wouldn't have seen, we can make better informed decisions, which was one of the bullets from the Open Water Data Initiative, using data to make decisions. Open data and transparency is there, increased communication, and then rapid development, and this is kind of the part that brings it all together. So I'll step through a few screenshots, and then I'm going to go a little rogue and do some demos, but I'll mention these really quickly, and I'll just walk through the slides. So So this slide is kind of the opening slide to my introduction for the Texas Water Dashboard, and this is now the third talk that used dashboard in a different term, but it's a very overloaded term these days. But this dashboard is where we deliver all the USGS real-time information from our entire observation and network in Texas into the fold. The reason Twitter's up here is because we do automated notifications for flood warning using two autonomous feeds on Twitter, and it's kind of a pilot effort for the USGS. This dashboard represents a mashup, which is a term that I think we should use when we talk about data from different entities. All of the USGS observation network is there, but also information from National Weather Service and other partners like the drought monitoring folks as well. So we're trying to put it all together. The reason I mention this is because our real-time groundwater and our groundwater quality sites are also in this, and I wanted to make sure you guys made that connection. The second application I wanted to mention is our Houston subsidence and groundwater management product. This came out last year, and this is a pretty significant effort. We've been taking water level measurements and looking at subsidence in the Houston region for about 40 years. This is done in collaboration with Harris Galveston Subsidence District, Lone Star GCD, City of Houston, Fort Bend Subsidence District, and Brazoria County. And the idea here is that we can use an application to look at changes in water level on an annual basis, as hundreds of water levels are taken every year in this region, but also to convey the message about the program and also talk about subsidence in some broad terms. Oof. I'm going to go with my gut here. I can't remember the next slide. I think I do now. So the other resource, and we'll have it up here in a second, is Geo Log Locator. And this is a national database of borehole geophysical logs available for the nation. There's a number that are available in Texas. The application was built here. It serves a national purpose. It has about 12,000 logs nationally, but there is a large score of those logs available for download and viewing in Texas in your backyard. So if you search Geo Log Locator, here's a picture of what it looks like. Essentially, there's some search functions here on the left. You can look for data of interest. It comes into many different formats. You can view and download that information from a single platform. So I wanted to make sure you guys are aware of that. The next application is our Hydrogeologic Data Explorer, and this is a new release. So we've been working with South Plains, Sandylands, and Llano Estacado, right here in the back, to develop an application that was the roots of some data collection, but also some analysis through one of our research reports, and actually data from the GCDs are included in here. This application exposes all of the data that we would manage for a program, but allows you to kind of click and build a strat column on the fly as well from the structure, which is kind of a cool feature. And I'll maybe demo that with a report out function, which kind of speaks to Aaron's point. So the last one I'll mention really briefly is GW Webflow, and I've got a couple slides to lay this out. This is a national investment from USGS at the headquarters level. So we have kind of long suffered with ModFlow groundwater models in a way to get those out into the hands of many. So we have our model archives, we publish our report, but it was, before this, kind of impossible unless you had somebody who was really an expert to kind of look at model inputs and outputs. And this framework was invested in from headquarters, but now we are hosting it and it is available kind of for local use to get those groundwater models off the shelf and back into use. It's a visualization tool that visualizes both the inputs and outputs of these models, and then kind of allows you to look across domains. It supports most ModFlow-based groundwater models, and I say most. If you have specific questions, I'll point you to Greg or others from the USGS. And then what we do is take those ModFlow files and we convert them into a format called NetCDF. And I'll leave that as is for now. But that format is a very performant format and allows us to interact with these data without burdening the application. Simple workflow diagram is that you have your model. There is a set of Python scripts to convert them. Those data are hosted on a server. In this case, it's a thread server, and this infrastructure already exists. And then once that kind of happens, it automatically shows up in the application. And this kind of gives you an idea of what it looks like. With this side-by-side picture, you can look at model inputs and outputs very easily to look at these data kind of for the first time through an application, but then to look for trends and explore and access some of that data. And there's kind of another shot. So let me leave that there, and I'm gonna go rogue. If you guys can't hear me, can you please let me know? I'll make sure I speak up. Okay, can everybody hear me okay if I speak like this? Got us hands in the back, okay. So except you can't see. Okay, well, let's see if we can get that back up. If we can't, I would ask you, make sure that this presentation is available. The tools that I'm referencing are available on a URL. The web address is webapps.usgs.gov. And feel free to browse around. The groundwater tools are available in this groundwater section that I was going to show here. Back around. Okay, so I'm going to show. This is the work that we've been doing with South Plains, Sandy Lands, and Llano Estacado, and it's under this umbrella called this Hydrogeologic Data Explorer. And essentially, the program data is in here. There's a couple other features. I'm just going to demo a few of them, but just to make sure that you're aware of what some of the baseline functionality is. And what I should say is that a lot of these frameworks, we've only built over the last 2 years. So there's a groundwater data framework now that we have, and so if you don't see yourself in one of these, then let us know, but I would suggest you probably see some functions that you're interested in here. The simple instructions, click on the column tab to build a hydrogeologic column, click on layers to look at the layers from the study, and click on legend to understand what you're looking at, right? So I'm going to add a little bit of data just so you guys, there's some contacts, they're organized by aquifers, we've got recent potentiometric contours as well as some of the groundwater flow paths. And you know, this is like your simple data viewer. I'm trying to be really gentle here. This is like your simple data explorer, and we can kind of click on well locations. This is a well that was used for the contacts of the Ogallala, and we access this from driller's logs, from TWDB, and clicking on this will actually take us out and get the actual well log that was used. So it's a lot of integration, as Aaron said, a lot of investments made to bring these pieces together. That's happened in some regard here. The column feature is this is kind of what I like. So it takes the surfaces from the conceptual framework and it makes it available to the application. So clicking around allows us to build this strat column on the fly for a number of, for the entire study area of interest. And this is a new feature for us, and you can get more information by kind of mousing over this. One of the cool parts for me is that report out function. So we've done all this work. Now, what are we going to do with it? How do we want to disseminate it? What are the possibilities here? Essentially, we can go in and this queries the database, gives us a nice header. All the logos are present. And then we can get all the information about this. So this is now mobile data. We can share this. The link is actually a permanent URL, so we can copy and paste this and send it to somebody in an email. Hey, I want to know, show me that report and send me that report. A lot of that's been done here. So that's kind of the framework for that application. If I step back, wanted to show the communication component here. This is again the groundwater program and subsidence program for the Gulf Coast region out in the Houston area. And just a high-level overview. Since it's a 40-year program, the idea is let's tell the narrative around this program. A lot of the data collection that's happened, we want to tell people what's happened in the past and what are the implications for now. So background information about the program, even a timeline to kind of put us in some sort of frame of where we are and where we've been. And then rolling down into the regulatory areas that manage this area, about our data processing, right? High-level metadata about our data processing and map creation, and then our report series that accompanies this work, I wanted to draw your attention to this middle component. So this is where you can actually explore the data. We can get into a viewer, look at change over time, look at contours, look at a lot of that. But the data themselves are actually connected here from Sciencebase. Remember, that was the library that we have. You can get the data itself or get the latest report. And then the last application that I'll show in brief is the Groundwater Model Viewer. And again, this is a pretty significant investment at a high level, but we now have this framework called GW Webflow, Groundwater Webflow, available for modular models. And the USGS, we just came back from California. California has 25 groundwater models that sit in their archive kind of unused, and they want to get that out off the shelf and put it into use under a framework just like this. So I think that's probably a common theme. Currently, we just released this earlier this year. We only have 6 models in here, but I'll just pull up really quickly because it's high level. You can see that kind of, each of the models described. We can get to the publication, we can get to the viewer, and if there are different scenarios, then they are listed out here. Let me go to the Houston area model. Just kind of give you a feel for what's here. So model inputs on the left with a simple pull down, so we can look at all the variables for model inputs. They've been loaded and converted. We can interact with them. We can visualize them. There's different ways to color them, transparency. We can overlay contours with that. So we're looking at the model top with the layer thickness. Gives us some analysis, and then these are link viewers. So we can look at model inputs and how that pairs with model outputs. And in this case, you can look at, here's head, and since this has a time component, we can actually look at a change in head over time. So we're back to 1963, we're looking at 82, 89, and 2009. And then, kind of interacting with the data allows us to look at, say, a time series for these data layers. So, think of this in broad terms. Thank you very much. Think of this in broad terms. We've done all the work. We're planning ahead for future scenarios about how these data can come together. We've done the work enabling that and then basically putting them into these databases. And once we do that, the power of the decision-making tool really comes into the fold here. So with that, I'll end, and I would love to entertain a question or two if anybody has them. Yeah, great question. So at this point, where we are, it's kind of in its infancy, and that is definitely where our trajectory is heading, but we aren't there yet. This tool was invested at USGS at a national level, and right now the implementation is a single Texas server, and right now we are architecting what the future looks like. There's been discussions with academia about the open source end of this. I think we need a little more time before we push that out, but I think it's coming very soon, if that makes sense. So yes, that is our end game. Any other questions?
You want to give them that website?
Yes.
Address again?
Yeah, it's on the end slide, but it's webapps, webapps.usgs.gov, and you should be able to find access to any one of these resources. Yes, Lynn?
We have handouts at our exhibit booth if you want to get more information on these products that Daniel mentioned.
Yep, and my email address is there. Thank you very much for your time.